So in this you can see in the figure there are several masses rotating in the same plane. Okay, so same plane is there, and you can see m1, m2, and m3, and here m4, all four masses can be seen there, and at the respective radius. For example, m1 will have the radius of r1 and m2 radius of r2. Similarly, m3 and m4 radius r3, r4 and all is given there. Okay, and the angle from the starting point, that is from the horizontal line OX here. So all the angles described for the given masses, so like that they are given as theta 1 for the mass, first mass m1, then theta 2, then theta 3, and then theta 4. So four angles given there, and these masses will rotate about an axis through the point O, you can see there, and then perpendicular to the plane of paper, and with a constant angular velocity of omega radians per second. And the magnitude and position of the balancing masses actually may be found by two methods. One is analytical and one is graphical. Okay, so let us see. I will show you both the methods. So first method, analytical method. So in this method, just by solving the equations, you will be getting the result and the balancing of this. So here the magnitude and direction of the balancing mass may be obtained analytically by this. So you can see these are all disturbing masses which are there. Okay, so to balance this entire thing, if an additional mass has to be given, so you have to find out this unknown mass, that is m here, which is shown by completely shaded blue color. Okay, so this mass you need to find out, and also you should know the angle. Okay, so angle, that is the angle theta. You can see from the origin OX, the angle is inscribed here up to theta. Okay, so this mass m and then theta, you have to find out. So you can go by this method. So first there are 6 steps to go for analytical method. So first step, what you have to do, you have to find the centrifugal force, that is product of mass and the radius, and exerted by each mass on the rotating shaft. So always the first step, you need to get the product of the mass and radius, that is m into r. Okay, that is the first step. Next, second one, you have to resolve the centrifugal forces horizontally and vertically, that is summation of horizontal force, summation of h, and then summation of v. So you know that summation of h can be taken as the cos components, the m1 into r1 cos theta 1 plus m2 into r2 into cos theta 2, and so on. If there are 4 masses, up to m4 will be there. Okay, and same way the sum of the vertical components of the centrifugal forces will be summation of v. So that will be m1 into r1 into sin theta 1 plus m2 into r2 into sin theta 2, goes on. Okay, so up to how many masses are there here in this? We have taken 4. So for 4 masses, up to m4 will be there. Okay, so m4 into r4 into sin theta 4, up to that. So once you get the second step, summation of horizontal forces and summation of the vertical things, so what you have to take next one? Third point, you have to calculate the magnitude of the resultant centrifugal force. Okay, so how you get the resultant? It will be summation of horizontal and the summation of the vertical. Okay, so that will be under root of summation h square plus summation summation v square, horizontal and vertical both, and you will be getting the resultant centrifugal force like this. And next one, to get the angle, that is angle theta. So theta will be calculated based on tan theta equal to summation of v by summation of h. Okay, so by doing this you can get the angle theta, and then the balancing force is then equal to the resultant force, that is but in the opposite direction. And finally you can find out the magnitude of the balancing mass. You know that Fc equal to m into r. So where m is nothing but the balancing mass and r is the radius. So from this you can calculate the unknown things, that is balancing mass can be calculated. Okay, once you got the Fc. Okay, so this is by the analytical method. Next, same way you can do the graphical method. You will be getting both the same answers. Any one method you can follow in the exam. Okay, so for the graphical method, you have to first draw all the position, like you are shown in this space diagram. You can see this is the space diagram. So with the given values, whatever value will be given with the angles and with radius and all, you have to first draw the space diagram, that is these positions, initial positions. Then once you get the space diagram, then you have to find out the centrifugal force value, that is same thing what you have done in the analytical method also. So that is product of mass into radius, m into r. Okay, because why you have not taken omega? Because omega is same. Okay, because omega, you can see here, it is having the same omega radians per second. The angular velocity will be same. So no need to again take for all the condition, because omega will get cancelled. Last conditions you have seen where omega would get cancelled. For other conditions you had seen. So like this, when it was done for the other cases, all this omega was cancelled. So same way here also, will not consider omega, so we will take only m into r. Next, third step, you have to draw the vector diagram with the obtained centrifugal forces, that is the product of the masses and the rate of rotation. For example, I will show you this figure. You can see this is the graphical method which is being done. So you start from the point A. So you know the FC1 value. So that is m into r. That product, you know the angle. Okay, you know the angle here. So this is the angle, theta 1. Okay, and this is the mass. So in this direction, that is this angle, you need to draw this FC1. And what will be the value for this FC1? It will be nothing but m1 into r1. Okay. So mass and radius will be there. You can draw this. Next, what is this position? FC2, it is 90 degree. 90 degree. So 90 degree you can draw this. And what will be the value of this? It will be FC2. FC2 is what? m2 into r2. Okay. Then this one, FC3, the angle whatever you got from that is theta 3. So just the same thing. So what will be the value for this? FC3, same thing, m3 into r3. So this will be m3 into r3. Next, FC4, this direction. So what will be the value for this? It will be m4 into r4. Okay. Now once you get all these things, what will be the remaining part? That will be nothing but the resultant. Okay. So if you connect the entire thing, because you should form a loop. When an entire loop is formed, then only it is said to be balanced. Okay. So what is left out will be nothing but FC value. Okay. So this will be the resultant. So from there you can get the resultant value. Okay. So you have to go step by step and get this polygon. Okay. So using this polygon you can find out the unknown thing. Okay. So that is nothing but the resultant. So that will be again balancing force and equal in the resultant force, but opposite direction. And finally you know that m omega square r is nothing but the resultant centrifugal force, and using the relation you can calculate the values, whatever left out values are there, unknown values, that you can find out. So this is about the graphical method. So we'll solve the problem based on this. Okay. So here in this problem you have got the 4 masses, m1, m2, m3 and m4. Okay. And the values of these masses are also given. So first mass is 200 kg, second one is 300 kg, then m3 is 240 kg and m4 is 260 kg. So the figure you can see. So this is the first mass, m1, 200 kg, then second one, this is m2, Then this one, this is M3 240, and then 260, this is M4. Okay, and the angle is also given, that is here 45 degree, 75 degree and 135. So here 45 degree up to first one, then 75 degree, this one. So how you will take from the origin? So that will be 75 plus 45. So 75 plus 45 will be 120. So from the OX plane origin it will be 120 degree, and similarly from this it will be addition of 45 plus 75 plus 135. So you get the total angle as 255. Okay, so these are given, and initial radius, that is corresponding radii is also given, that is 0.2, 0.15, 0.25, 0.3. So these are the radius. This is R1. Then similarly here is given the value of R2, and here is given the value of R3 0.25, and similarly here R4. So all masses M1, M2, M3, M4 are given, and R1, R2, R3 and R4 also given. Okay, and also they get the angles. So from the data you get all the masses M1, M2, M3, M4, then R1, R2, R3, R4, and even the angle theta also you will be getting. So for all the angles you will be getting. Initially it will be 0, first mass will be having 0 degree, then from the plane it is 45 degree, second one, then third will be 45 plus 75, then the fourth will be 45 plus 75 plus 135. So that is 255 degree, the fourth one. Okay, and he has given that you have to find out the position and the magnitude of the balance mass required if the radius of rotation is 0.2 meters. Means you have to find out the disturbing mass, that is for the disturbing mass what is the balance mass. So let us take this unknown mass m. So the value of this you need to find out with an angle. So mass and angle for this unknown thing you have to find out, and he has given that radius is 0.2 meter, means he has given the radius r. Okay, so you have to find out the value of m and also the angle theta. Okay, so this theta and m you need to find out. Okay, so we will start the problem. So first you need to take the values of m1 into r1, m2 into r2, m3 into r3 and m4 into r4. So correspondingly you take, this is theta. So m1 into r1 is 200 into 0.2, you get 40. m2 into r2 you get 300 into 0.15, you get 45. m3 into r3 you get 60. m4 into r4 you get 78. Okay, now we will solve this problem by both methods, by analytical and graphical. Okay, but you can follow any one method in exam. Okay, I will just give you 2 minutes time. You can just take down the values and try to get this answer, and even plot this figure. Okay, then I will tell you how to proceed. So m1 into r1, m2 into r2, m3 into r3 and m4 into r4. Okay, next the analytical method. So the space diagram you have seen. So summation of horizontal forces, that is m1 into r1 cos theta 1 plus m2 into r2 into cos theta 2 plus m3 into r3 into cos theta 3 plus m4 into r4 cos theta 4. Okay, so you know the masses m1, m2, m3, m4. You know the angles theta 1, theta 2, theta 3 and theta 4. All four angles are also known to you. So substitute the value. You will be getting the summation of horizontal forces, one value, that will be in kg meter, because mass into radius you are taking, so mass is in kg, r is in meters. So you get value of summation of horizontal force, you get the value in 21.6 kg meter. Same way you will be resolving this vertically, that is summation of v. So same way m1 into r1 into sin theta 1, m2 into r2 into sin theta 2, plus m3 into r3 into sin theta 3, plus m4 into r4 into sin theta 4. So you know the values, again substitute the value, and you will be getting summation of vertical forces as 8.5 kg meter. Okay. Next, the resultant can be found out from the root of summation of h square plus summation of v square. So you get the resultant value as 23.2 kg meter. Okay. And the unknown things can be calculated from this. You know that the resultant is nothing but m into r, because that is the centrifugal force which is remaining resultant. So you know that Fc is equal to nothing but m into r, that is the resultant. And you know the radius is given in the question, that is you have to find the mass at radius of 0.2 meter. Okay. So 0.2 is known to you, so radius is given 0.2, and you got the resultant as 23.2. So mass can be calculated from this. So what will be m, that is resultant, divided by the radius. So you get 23.2 divided by 0.2, you get the mass as 116 kg. So 116 kg you will be getting the mass. And then the angle part, so tan theta equal to summation of v divided by summation of h. Okay. So summation of v is how much? 8.5. Then summation of h is 21.6. So you get summation v by summation h as 0.3935, and tan inverse of this one you will get the angle, that is theta dash will be 21.48 degree. So what is this 21.48 degree, that is theta dash, that is the angle of resultant, that is for the mass of here what you got for horizontal mass, that is for 200 kg from there. So therefore the angle of balancing mass of the horizontal plane mass of this 200 kg actually, so it will be the theta dash is being measured at this point. So actually you get the theta dash here, but actually what you get, you should get the opposite direction, because if you take here it will be in the same type of quadrant, otherwise it will not balance. Okay. So it is in this direction, opposite to that. Just take one more line here opposite to this. So whatever here, this will be there. So this will be the actually the angle theta. So theta will be nothing but extra 180 degree to the angle theta dash. Okay. So whatever you get here is to be taken in this plane or in this quadrant. Okay. So you will be getting theta will be 180 degree plus 21.48, because this is the same thing, just you are extending this line. So the angle here, total angle will be here 21.48, already you got this, so plus 180 degree. So you get total angle as 201.48 degree. So the answer will be theta is 201.48 degree. Okay. So one is the mass 116 kg and another theta is 201.48 degree. So this is one more answer. So these things you have to find out. Now this we are done by analytical method. So same way we'll be doing the graphical method also. I think first I will give 2 minutes, so I can just solve this. So next we'll go with a graphical method. So the magnitude and position you just calculated now, that is m1 into r1, m2 into r2 and m3 into r3, m4 into r4 you have calculated. So you got the values 40, 60, 45, 60 and 78. So using this space diagram, whatever angle is there, so you should get the values whatever is there. So you know that from the figure, what is the first thing? this is the 0 degree, right? So 0 degree, what, and this is the first mass, what is the value here? 40. Okay, so at 0 degree you have to take a scale of 40. So let us take 40 kg meter as 40 mm only. Okay, so 1 kg meter you will taken as 1 mm. So you get AB, this one you will get as 40. So 0 degree. So take a scale and then draw it in a convenient scale, and you take the draw, and whatever is there, A to B 40, you just draw A to B straight line at 0 degree. Next the second mass M2 into R2, so that is 45 at an angle of here 120 degree. This is what this is given, whatever angle is given here, I think 75. Okay, so 45. So this angle you have to take a line of 45. So let us take 45 units. So draw at this angle. Next another angle here in this direction. So the value is, next one is 60. So 60 units in this direction. Next, the last one, it is here downwards here, it is 78. So 78 here downwards. Okay, so once you get all the things, so this is 40, 45, 60, 78, and the last one, whatever is there from the origin, so that will be nothing but, which is left out, that will be the resultant force. Okay, so once you get the closing set of this polygon, you measure the value of AE. Okay, so this AE distance, whatever you will be getting, so measure this AE, and this AE will be resultant centrifugal force. Okay, so that let us after calculating, you get AE as 23 kg meter. Okay, so once you get the thing AE, so the balancing force will be nothing but equal to the resultant force, but opposite in direction. Again opposite, same thing. So m into 0.2, that will be nothing but a vector EA 23. So using this you get m value as 115 kg. So same answer what you got in the analytical method, you get the same answer here. So analytically you had got 116 kg. So by graphical you get 115 kg. So nearer to that. And angle, so just measure the angle. So this is the resultant thing, but it will be opposite direction, will be here, opposite will be here. So you measure this angle from this angle to this angle. So this angle you will be getting 201 degree. Okay, so whatever angle is there here, just inscribe here. So this line you take it over here and then extend it here to get the angle. So from there, if you measure the angle, you get angle as 201 degree. So in analytical you had got 201.48. So by graphical you get 201 degree. Okay, so cross check the answer with analytical and graphical.